Okay, Lexi, let's go ahead and finish up lesson 136. So we left off on 19. We kind of stopped right in the middle. What you figured out when we were meeting was that you took and added up all of the data in number 19, and you figured out that the mean was 44.95. Mean is simply the average, okay? And you use that a lot. The median we talked about is always going to be your middle number. Just like if you're driving on the highway, the median is that grassy area in between the two lanes of travel, north and southbound on I-75. So median always means middle. So you're looking for the middle number. You always have to list your numbers in order. You can go least to greatest or greatest to least. I have just always done least to greatest. It just makes sense to me to put them in that order. You can put them in a column, as you see over here to the left. Right over here. Or you can put them the other way, like I did up here in number 18. You can see here. It doesn't matter how you do it. Typically, I personally like the column. It just depends what kind of room I have on my paper. But I find it easier to find the middle number this way. The middle number is always going to be directly in the middle. Now, when you have an odd amount of numbers, that you're going to end up with one middle number, which makes sense because if you had, let's say you had 9 numbers, you're going to have your first number, your second number, your third number, and all the way through 9. So let's just put this on here. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you find the middle, you're going to have to count 4 on either side of it. And your middle number would end up right here. Okay, so you have 4, 1, 2, 3, 4, and 1, 2, 3, 4. So there's your middle number. But when you have an even number of numbers, it changes that up a little bit. So let's see what that does. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put one more here for the 10. Okay, in this case, you have 4 on either side of the middle number, but the middle number would generally be right in there. So what do you do when you have 2 middle numbers? You simply take both of those numbers, like I'm doing right over here in this set of data. You add them together and you find the average. Okay, so in this case, the average on number 19 of those 2 numbers would be 44.5. You just add them up, 43.2 plus 45.8, and divide it by 2, and that is your median. It's getting a little bit messy, I apologize. And then we talked about the mode, meaning most. And 50.6 is the number that occurs the most in number 19. Let's look at 20. So we have a set of data here representing the number of miles per day that Mr. Thompson drove each day in February. So each day is listed there. Now this is an interesting set of data here because one of the things that in this lesson, if you recall what the lecturer was saying to you, is that sometimes you're given a set of data and you have to determine which is the best measure of central tendency for that set of data to use to determine anything. So in this case, most generally, I probably would want to know, okay, well, what was his average miles per day that he drove? I want to figure out, on average, how much does Mr. Thompson travel in a month, okay, per day? So in this case, I notice here he's got, if you kind of scan the numbers, you know you've got 7, 10, 18, 5, and you kind of scan through and you see, okay, I could find the mean of this, meaning the average, but my average is going to be thrown way out of whack because of this one number in here where he probably took a long trip. So really when you're thinking about how much he travels on average, that trip probably is not something he does all the time. So that number is going to throw out any calculation of a mean. And they have a name for that number. When there's a number like that thrown in a mix of data that's like way out of whack, they call that guy an outlier. And an outlier, when you're figuring out a mean, can really throw your data off. Okay, so the mean is not generally something that we would use when you have an outlier in the mix. Okay, what you use then is you flip over to finding the middle number. Because if I were to put all these numbers in order from least to greatest, that 320 is going to be way down at the bottom. My first number is going to be, let me find my lowest number really quickly. It looks like it's 5 if I can scan it quickly. And then all these numbers in between. Okay, but your middle number is going to really give a little bit better picture of what the average would be. Okay, because as you list them in order, that average number is usually kind of like your middle number, right? So the median is going to give you a little bit more accurate reading and understanding of what that statistical data is actually trying to communicate to you. The 320 is going to be way down here. He's way off from any of the other numbers and will throw out your calculation of a mean. But by listing them in order and finding the middle number, it kind of helps you to identify what the mean would be close to being. Okay? So that would be the best method there. The mode isn't really something you would use in that particular data because he may travel differently each day, but the mode is going to tell you the one that occurs the most. Remember that. So in this case, I don't know what it is. I'm trying to scan quickly. I see a couple of 5s, a couple of 6s, a couple of 19s. So the mode isn't really going to help you to determine anything about finding some valuable information with his travel. Number 21, this table shows the ages that each member of the Rodriguez family when they first received their driver's license. So this speaks something about the Rodriguez family. So the question is, gosh, I wonder in the Rodriguez family how old most of them are when they get their driver's license. So you can look through here and you see 16 all over the place. And if you were to go through there and circle all that, the best measure of central tendency for this set of data would be the mode. Because the question is, what is the age of the Rodriguez family members when they get their, how old are most of them when they get their driver's license? So the mode would be the one that would make the most sense there. Okay, and we can talk more about that when we're together again, if you like, and try to understand that a little bit better. But sometimes it's one of those things you have to sit down and try to make sense of and pick through what the problem is asking for, what the data is providing, and what you're trying to figure out. Number 22 is your word problem. Let's read this. We have two numbers that have a sum of 24, and 7 times the first number minus the second number is equal to 16. Okay, so what I see here, if you listen to this, there are two equations that we're going to write here. So this sounds like a system of equations. Two numbers have a sum of 24. And 7 times the first number minus the second number is equal to 16. How do I know that? How do I know it's two systems? Because two numbers have a sum. So there's something we're setting equal. So let's do that. I'm going to change the color of my pen because this is a darker page. Actually, no, I'm going to move down here where I can write on the white. Two systems. So the first equation is having two numbers that have a sum of 24. That's fairly simple. That's taking x and adding it to y and getting 24. We're not told it's the same two numbers, so we have to name them x and y because they represent two different numbers that total to give us the sum of 24. The second equation says 7 times the first number, okay, well, our first number was x. So 7 times the first number would simply mean 7 multiplied with x minus the second number, which the second number up here was y, is equal to 16. And there's our system of equations. I'm going to try to erase those little lines really quickly here to get rid of them, and I'm going to erase too much. I have to rewrite that. All right, so we have x plus y, 7x. There we go. Okay, so we learned in the past, how do we solve for x and y here? And by the way, the last question of this is, what is the smaller number? So we have to figure out the value of x and y. When we figure out those values, one of them is going to be smaller than the other, and we're going to pick the smaller solution, and that's going to be the answer to this question. Okay, and remember, the two solutions that we find for this are going to be the numbers that I can plug them into both of those equations and make them true. So they have two solutions they each have one set of solutions that will work for both of those equations. All right, so we look to add these together. That's what we've learned to do. And we're looking to see how are my equations already set up that I can just do the addition, or do I have to change anything so that I can eliminate one of those variables? But what I notice here is that when I look at this right here, plus y minus y, That's going to get rid of my y's, and that's what I want to look to do. So I'm going to add together x plus 7x, and I will get 8x. These cancel each other out, and I end up with 40 over here. Okay, I divide by 8, and x is equal to 5. Okay, so now I know that the x value, 5, will work in both of those equations. But let's figure out what y is now. So I'm going to take the easier of the two equations, which is going to be the first one up there, and I'm going to substitute 5 in for x. So I have 5 plus y equals 24. Use our algebra here to solve for y. I have y equals 19. Okay, so what this says is that when x is 5, or rather x can be 5 and y can be 19 in both of those equations up there, and make those true. Okay, but the question was, what is the smaller number right up here? The smaller number then is actually 5. So that is the solution, or the answer. The solutions are 5 and 19, but the answer to this problem, they're asking for the smaller one, which is 5. So 5 is your answer to that problem. Okay, if any of this wasn't clear, especially on the measures of central tendency, we can get back together on those on Friday, and you can save your questions to ask me then. Okay, so hopefully that was helpful. Have a great day, and I will see you on Wednesday, Lexi. Take care.